Hello, and welcome back to Summarize Science. What if an AI could learn the general rules of physics just by watching simulations of everything from acoustics to exploding stars? A new paper introduces a foundation model called WALRUS, which aims to become a general-purpose tool for simulating our physical world. This could revolutionize how we do science and engineering by making complex simulations incredibly fast. The big problem is that traditional simulations are slow, and previous AI models often fail at predicting things long-term because tiny errors build up and cause them to become unstable. They also struggle to learn from the huge variety of data out there, like different resolutions or dimensions. The researchers behind WALRUS developed several new techniques to solve these problems. These include a clever method called patch jittering to improve stability, and a way to treat 2D data as flat planes within a 3D world, letting the model learn from both at the same time. At its core, WALRUS is a type of AI called a transformer, similar to what powers models like ChatGPT. But instead of processing words, it processes snapshots of a physical system over time to predict the very next moment. This diagram gives a high-level view of how data flows through the model, getting encoded, processed through space and time, and then decoded to form a prediction. To become a foundation model for physics, WALRUS was pre-trained on an incredibly diverse set of 19 different physical scenarios. As you can see here, this included everything from the turbulent formation of interstellar clouds to the violent aftermath of a neutron star merger. This is like sending an AI to university to get a broad degree in general physics, rather than just studying one specific topic. And the results are impressive. When tested on brand new tasks it had never seen before, WALRUS consistently outperformed previous state-of-the-art models. These charts show the error for various 2D tasks, where a lower bar is better and WALRUS, in blue, is almost always the winner. It's not just a little better. In many cases, its predictions are significantly more accurate. But here is the most fascinating insight from the entire study, which is all about the importance of that diverse training. When the researchers trained a version of the model on a less diverse, more naive set of data, it actually looked better on those specific training tasks. You can see here that the naive model, in red, has a lower error than the half-walrus model in blue. However, when these models were then tested on new, out-of-distribution problems, the story completely flipped. The model trained on diverse data consistently beat the naively trained model and one trained from scratch. This proves that for building a truly useful and general foundation model, a broad, diverse education is far more important than achieving a perfect score on a narrow exam. So, let's recap what this all means. WALRUS is a new, highly accurate foundation model for physical simulation that succeeds because of its massive scale and, crucially, its diversity-focused training. It shows that teaching an AI a broad curriculum of physics makes it better at solving new problems. In the future, models like this could become indispensable tools for scientists, allowing for rapid prototyping and discovery in fields that currently rely on slow and expensive simulations. Thanks for watching.